Hello there and welcome to Mastery Tutoring. I'm Tutor Kara, and today we're going to be doing this amazing question from the 2018 paper to IEB final exam, question 4C. If you have not seen question 4A and B, please look for the videos on the list of our videos and then watch them, because this video only focuses on question 4C. And for those who are new to our channel, please subscribe to our channel and share the link to this video with your friends. Be the first one to share this video to your school related social media groups. That would include your WhatsApp and Facebook groups. Without further ado, let us solve the question. So in the diagram below, so the question reads, in the diagram below, P, Q, R and S are points on the circle. QS and PR intersect at point T rather, and the line from V is a tangent at P. Angle QRP is equal to 56 and angle RPV is equal to 70 degrees. And then we are required to find the size of the of angle RST. So as you can see on the diagram, all the points have been indicated for us to bother indicate anything, and then also the angles have been divided into ones and twos. Like for example, Q is divided into Q1 and Q2, T is divided into Q1, Q2 and Q3, and then obviously we have points on the circumference as the P, Q, R, S are on the circumference of the circle. So now we don't have to construct any lines, we don't have to put any additional information on the diagram. However, if you feel like you want to add some information that is going to help you solve the question, then you might as well just go ahead and edit. But then according to the way I see it, I feel like we don't have to add anything on the diagram except our solution. So now we're going to jump on giving the solution of this question. So now, how do you go about that, right? So on the diagram, you can see that P1 is equal to 56 degrees. Angle P1 is equal to 56 degrees. So let me put it here. P1 is equal to 56 degrees. Now the reason to this is because if you can check tangent, so this is the angle formed okay, let me just write the reason here and then I'll explain after. Tangent PV and chord. So angle P1 is equal to 56 because they are subtended from tangent PV and chord PQ rather. So this angle, let me use a different color. This angle is equal to this angle. Visit your theorems from grade 11 and check out a theorem that talks about tangent and a chord. You'll see that the one that I'm talking about here. Okay. So now we can also move on to say now angle P1 plus P2 so P1 plus P2 plus degrees sum up to 180 degrees. So basically what I'm doing here, I'm looking at all these angles that are along this line, along the straight line PV or along the tangent PV. Add all of these angles, they give you 180 degrees. So now the reason to this is it's angles on a straight line. Angles on a straight line. Okay, so we can make P2 the subject of the formula and then solve for P2. P2 is equals to 180 degrees minus 70 degrees and then minus P1. But P1 is I've already made to 56 degrees, so I'm just gonna go ahead and put 56 there. So now this gives me P2 to be equals to 54 degrees. P2 equals to 54 degrees. Celsius. Oh, degrees, not not degrees Celsius, but just degrees. And then also, when you look on the diagram, we can see that RST angle is equals to P2. Now, this is the angles are on chord QR. So therefore, they equal. Now, therefore, we can safely conclude that KRST is equal to 54 degrees. Here's the answer to the question. So that was question 4, question 4C1. Question 4C1, as you can see here, it says question 1, find the size of the angle RST. So now we do question 4C2. So C2, it says if Q1 is equal to 37 degrees, then explain why QS is not the diameter of the circle. Okay, so since they've given us the angle of Q1, it is much easier for us to calculate angle R1. When you look on the diagram, right, angle R1 equals to Q1. Now the reason to this is because the two angles are subtended on arc PS. They are subtended on arc PS. Therefore they equal. So R1 is equals to 37 degrees. Okay. Now, when you check now, angle R is equals to R1 plus 56 degrees. According to the diagram there. So R1, excuse me, R, not R1. This is supposed to be R. R is equals to 37 degrees plus 56 degrees, which is up to 93 degrees. Now, before we close this, I want us to remember something. Let me quickly draw a circle here. Suppose, okay, this is a bird circle. A proper circle. Suppose we have a circle like this, and then there's a line that divides the circle into two equal halves or into semicircles. So therefore this would make it our origin. Allow me to call this O, right? So according to these theorems, according to Euclidean geometry theorems, if you draw a line, a chord from, let's say this is A and this is B, and then you draw another one from B to a point there, let's call that B. So we have two chords, AB and BD. Sorry guys, my drawing is not really accurate. So, but then imagine these lines, AB and BD as straight lines. So according to these theorems is that if you draw these two chords and they intersect at that point there, now this is going to be 90 degrees. The angle there, that form there, is going to be 90 degrees. It doesn't really matter as to where these lines intersect. Even if maybe I were to draw another one there and then draw another line there, and let me call this C. This angle there is 90 degrees. Doesn't matter where exactly they are. Let me draw another one just for emphasis. Okay, that one was bad. That line was bad. Let's draw another line. I'm going to call it here, right? This angle is going to be 90 degrees. It doesn't matter where exactly they intersect. As long as two chords intersect on the circumference and then also they're starting from they are on this semicircle. They're going to form a 90 degrees when they intersect. So now, in addition to what I just said here, so this simply means that E is equals to B is equals to C, which is 90 degrees. This is just an example, right? So now when we go back to our diagram, let me quickly scroll up to the diagram. Now, so we somehow have a similar approach here, you know. So if this has to be a chord, it means this angle here has to be 90 degrees. So it means this angle here, the whole angle. So it means this whole angle here has to be 90 degrees. So 56 plus R1, which is 37, has to sum up to 90 degrees. If it doesn't sum up to 90 degrees, therefore we can't say QS is a what is it? Is a diameter of the angle of the circle, because this angle has to be 90 degrees. Now let's go back to our calculations. So as you can see here, when you add R, that is R1 plus 56, which gives us angle R, it sums up to 90 degrees. Because of this, QS can be the diameter of the circle. So QS So there's our reason there, right? QS cannot be a diameter because angle R is not 90 degrees. So that's it, folks. I hope you learned something from this. Like I said, I'm a tutor Kara, and I thank you for joining me as I solve this question. And leave a comment if you have any question or recommendation for these videos. And don't forget to subscribe to our channel. Have a nice day. Goodbye.